Okay, good morning, class of 4 viewers. This is the final and last video in the muscle series where we cover muscle contraction. I believe the first one was about what are muscles and how the musculoskeletal system is in general and how it works to cause movement. The second one was about the structural unit of a muscle and the functional unit, the sarcomere, and its structure. And this one is going to cover muscle contraction, how the sarcomeres and the actin myosin filaments work together to cause movement and a contraction. So this is really what's going on when you're pumping iron in the gym or walking or even breathing for that matter. It's these muscles, right? It's this process right here that causes your muscles to contract and allow you to do the things that you can do. So this process is very important. Um, This is very generalized, just want to put that out there. It's extremely brief. Obviously, when you move on to your higher level courses in university, it'll be much more complex, but this is a very brief overview, a rough, in a nutshell, muscle contraction that's good enough for the high school level, I would say. So let's get to it. Okay, so muscle contraction obviously begins when it's stimulated by the motor neuron. The stimulation by motor neuron signals the muscle that it's time to contract. Let's do it. So the signal is given, it's stimulated by a motor neuron, okay? I apologize for the beeping, that's just our fire alarm needs to be replaced with batteries. Sorry about that. Okay, so once it's been signaled by a motor neuron, calcium ions are released from the sarcoplasmic reticulum. And remember, that's the endoplasmic reticulum that surrounds the muscle fibers, the muscle cells. So it causes calcium ions to be released from the sarcoplasmic reticulum. These calcium ions causes binding sites for myosin heads to be revealed. So there's a barricade, some molecule that's barricading and preventing the myosin heads from binding to the actin filaments. Calcium ions bind to that, revealing the binding sites for the myosin heads and the actin filaments. So calcium causes that to be exposed. Myosin head filaments are then able to bind to the actin filaments. This forms a cross bridge. So now that they've been signaled by a neuron to contract, and we have calcium ions which have removed that barricade preventing the myosin heads to bind, these myosin heads are now attached to the actin filaments. They formed what we would call a cross bridge here. Now this cross bridge is just the myosin heads attached to the actin filaments. So now an ATP molecule, adenosine triphosphate, which is the main energy molecule, binds to the myosin heads and causes them to break the cross bridges. So they attach and they cause them to break away from the myosin head, from the actin filament, sorry. They bind to the myosin head and cause them to detach from myosin heads to detach from the binding sites. Next, the ATP molecule is hydrolyzed to ADP plus phosphate, but still bound to the myosin head. So it's hydrolyzed into ADP, adenosine diphosphate, and phosphate, causing the myosin heads to change their angle. Now this right here is key because a lot of people will write on a test that, oh, the ATP is hydrolyzed into ADP and phosphate and is immediately released. Now that's not true at all. The ADP and phosphate are still bound to it. In fact, it's very crucial that they're still bound because the next step, the heads are now in a cocked position as they are storing energy from ATP. So although they're hydrolyzed, they're not released yet because that energy is in a different angle, cocked position. So they're storing energy from ATP. Now, heads then attach to binding sites on actin filaments that are further away from the center. From the center of the sarcomere. So now that we have them detached and they've changed their angle, they're going to bind to somewhere further away from where they were before. They're going to bind to that area. Okay? Now, this is what causes the muscle contraction. The ADP and phosphate are now released. Now they're released. And the heads push the actin filament inwards towards the center of the sarcomere. This is called the power stroke. This power stroke is the key. If it's one thing you can remember from this video, is it's the power stroke that causes the muscle contraction. The power stroke pushes the actin filaments inwards towards the center, shortening the muscle fiber and generating that force needed to contract. So whenever you're pumping iron at the gym, doing dumbbell curls, or whatever you're doing, it's your It's the myosin head forcefully pushing the actin filaments inwards together. This generates the force needed for a contraction right here. This causes the muscle to shorten and causes your bones to change that angle, and it's what causes your muscles to contract. This process right here is very, very important. Please, 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 please write this down, pause the video, and write every single thing you can down right now. It's extremely important. In case you weren't very clear about it, I'm going to show you a diagram I have in one of my textbooks right here. Right here. So you can see in step number 1, it forms the cross bridge. Step number 2, the ATP causes it to detach and change. And then step number 3, it's hydrolyzed into ADP and phosphate and in a cocked position. Step 4, it attaches somewhere further away from the myosin head. And 5 is finally the power stroke. The movement is inwards towards the center, causing the muscle to shorten and contract. And there you have it, folks. That's muscle contraction. If you have any questions, please leave a comment, and I look forward to making more videos. Thank you very much.